everyone, welcome to Pepcoding. So in this video, we are going to start the next question from our arrays and string module. And the question that we have is first missing positive. Okay, so it is a really interesting question, but the constraint that we have is you have to find a solution that will take O and time complexity. Okay, because there are many methods to solve this question, but we have to give it a optimized method, a method that will run in O and time complexity, and also we have to make sure that we will take the constant extra space, that is O1 of space. Okay, so what we need to do is we'll be given an unsorted array, right? We will be given an unsorted array, and in that array we have to find the first positive missing number, right? First positive missing integer. So our positive missing integer starts from 1, right? From greater than 1, I have my positive integers, right? So I have to find which first positive integer is missing. So let us go to the board and we'll discuss it there, what it means. Let us see what this question means. So I'll make an array first of all. Suppose this is my array. Okay, 1, 2, 3, 4, 5, 7. Okay, so we'll take some elements here. So suppose my elements are let us say 6, 6, 5, 9, 2, 8, 1, 3. Okay, these are some elements in my array, and what I need to do here is I need to find first positive missing integer, right? First positive missing integer you need to find. So how you are going to do it? So it is a really easy task to do. See what you can do. You can simply find, see my positive integer ranges from 1, and the maximum this array can hold, the maximum this array can hold is, if this is 0, 1, 2, 3, 4, 5, 6, right? So maximum element, maximum positive integer that this array can hold will be, suppose 1 will come here, 2 will come here, 3, 4, 5, 6, and 7. So it can hold the elements till 7 only, right? From 1 to 7 only, because if all the elements will be present, if suppose if all the element will be present, then also we can only have the elements from 1 to length of array, right? 1 to length of array. So in this constraint, we'll get our answer. Okay, suppose if all the elements are present, then what will be our answer? What is the first positive number that is missing? I will say, if all the elements are present, then the first positive integer that is missing is n plus 1, that is here it will be 8, right? 1, 2, 3, 4, 5, 6, 7. So 8 is the first element that is missing. Okay, if the array will contain, all the element, if array will contain all element from 1 to n. Okay, from 1 to n, if array will contain all the element, then the first missing element will be n plus 1. Okay, so this will be my answer if array will contain all the elements from 1 to n. Okay, now let us talk about some more cases. Some more cases could be, suppose first of all, first number that will come, first number that I need. Here we can say first number from where I can start. First number from where I can start, and that number would be 1, right? Because 1 is the first positive number. So the first number from which I can start my search could be 1. Okay, so let us see some methods to do this. Okay, we'll not implement all the methods here, but we'll code the optimized one only, that is the O1 time complexity. So first of all, I'll discuss this O1 square solution. Okay, so what this could be, see what I will do. I will first of all, I need to check a positive integers, right? First missing positive. So I'll check for 1. I'll check for 1. So in this loop, I'll check if 1 is present or not. Okay, I'll run a loop from 0 to n, and we'll check if present or not. If it will return true, then I will check for 2. Right? Now here, when we will check for true, 2, so I again run a loop from 0 to n and will check if 2 is present or not. So suppose if 2 is present, 2 has returned true, so I'll check for 3 now. Okay, so when I'll check for 3 now, I'll again run a loop from 0 to n and will check if this 3 is present or not. Where is this 3? Here is this 3. So 3 is saying yes, I'm present, so we'll check for 4. So we'll again run a loop from 0 to n and we'll check if 4 is present or not. So if 4 is present here, if 4 is present, 4 is saying no, I'm not present. 4 is saying no. Okay, so 4 has not returned true, right? So my first positive number that is missing, we also write positive, right? Because we are finding only positive missing number. So first positive number that is missing will be 4. This is the first positive number missing. And also remember that our numbers is starting. Numbers can also be negative numbers, right? Okay. Here in this array, number can also be the negative numbers, but the range of the positive integers is greater than 1. Okay. That is we will consider positive integers from 1 to n, right? Positive integers from 1 to n. So for us, the number should lie in this range. Okay, for us the number should lie in this range, in this array, right? If there is some number missing, if there is some number that is missing in this range, then that will be the answer. Okay, the first number that is missing in this range will be our answer. So I hope that the question statement is clear. Okay, so what we need to do, let me reiterate that. So in this we need to find the first missing positive number. That is suppose we have a array that has length n. Okay, so we have to find the element from 1 to n, the first element from 1 to n that is missing. Okay, if 1 is the first, if 1 will be missing, then 1 will be the answer. If 2 is missing, right, 1 is present but 2 is missing, then 2 is the answer. Okay, then and suppose if all elements from 1 to n are present, right, 1 to n all the elements are present, then in that case n plus 1 would be the answer, right? But we cannot write this general answer, right? For first case we cannot write if first is missing, or if all are present. We have to write a general code. So how we can do that? So one approach we have seen, that is the O n square approach, right? So what we are doing in that, we were running a loop for the numbers first, which we were searching in it. We were running a loop from for n times. Okay, and we were doing that work for n times, right? So that is why it is an n square solution. Now let us talk about some more solutions. Some more solutions could be someone can say, I'll sort this array, and okay, let us take now one negative number also. Okay, because that will give us a better insight. Suppose this is -5. Okay, suppose this is -5. So now what we will do, we'll simply sort this array first of all. Okay, let us sort this array. So if I will sort this array, then the answer would be, it would be like let me rub all the elements. So when this array will be sorted, so I'll get in the first place I'll get -5. Okay, in the first place I'll get -5. After that I'll get 1, then 3, then 2, and then 3. Okay, and then after 3 I have 6, right? 6, and then I have 9. I have 8 also. 6, after then 8, after that 9. Okay, these are the elements of my array. So now I sorted my array. Okay, I have sorted my array. So let me put it this side, and this will be my main array now. So after sorting, what I will do, okay, so after sorting, what I can do is, see, I have sorted my array, right? After sorting, I'll check where is my 1. Why 1? Because I need to find first positive integer missing, right? First positive integer missing, that is missing. Okay, so I'll find if 1 is present or not. Okay, So if suppose if I'll get my 1, if I'll get my 1 in this array, okay, so after 1 all the element would be 1 greater than the previous one, right? Because see, when I have 1 and if second number will be present, then after 1 2 should come, right? Because it is sorted array, it is a sorted array. So if 2 is present, then 2 will come after 1 only. If 3 is present, then 3 will come after 2 only. If 4 is present, then 4 will come after 3 only. If 5 is present, then 5 will come after this. And suppose if some number is missing, suppose 6 is missing, so after 5 we'll have 7. Okay, so here we can check that okay, one number is missing, so this 6 is missing from here, right? So this is this can give us answer. But see, one more thing, why we are finding 1? Because negative number can also present, right? Negative number will present in the start, but we don't have to do any work with our negative numbers. We just need to start from 1. That is why I'm finding 1 also. Okay, so this will give you some insight of our approach. Okay, but this approach will take how much time? I'll say n log n. Okay, why n log n? Because sorting will take n log n time, and after that searching for the missing element will take. Okay, so overall time complexity will be big of n log n. Okay, which is also not an optimized approach. Okay, so we can again need to optimize this. So how can we optimize this? So for this we have a method. Okay, we have a method, and that method has 3 steps. Okay, our algorithm has 3 steps. So let me tell you those steps. First of all, we will learn how to do that, and then after that I'll tell you why we are doing this and why it is working. Okay, so it is somehow similar to this sorting kind of approach, but will not actually sort the array in this. Okay, but first of all, we need to find this 1, right? We need to find this 1 in the sorting order also, and in this also we'll find the presence of 1. Okay, so the 3 steps that we have. Okay, let us talk this. We'll talk about this in next page. So let's go to next page by taking this array. Okay, we'll take this array. Original array was, so we'll take this array. Oh. We have this array. Now we need to follow 3 steps in this, right? What are those 3 steps? Let me tell you. Step 1. So step 1 is mark the presence of 1, and also mark out of range elements. Okay, out of range elements. It is our step 1. Okay, mark the presence of 1 and also mark out of range elements. Now step 2. I'll tell you what are these steps. Here I'm just telling you what we need to do. Okay, what is our algorithm? So this is the first step, and after that the second step that we will follow would be, here will map elements with indices. Okay, we'll map element with index or indices. Okay, we'll write index here with index. Okay, map element with index. And in the third step, these are the 2 main steps, and in the third step, find missing element. Third step is just find missing element. Okay, these 2 steps will take us to our destination, and here we'll just get the output. Okay, so let us now do the work, and let us see that how we are going to use this algorithm or this method. Okay, so let us follow the first step. First step was mark the presence of 1. So how I can mark the presence of 1? For marking the presence of 1, what I will do is I will simply take a boolean. Okay, I will simply take a boolean, and in that boolean what I will do, suppose my boolean is one. Okay, and what I will do, when I will find 1 in my array, initially I started from false. Okay, and when I will find 1, if if I will find 1, then mark boolean 1, mark boolean equal to true. Okay, mark this true, that yeah, you got this one in your array. Okay, you got this one in your array, so mark this boolean true. Okay, so first of all take a boolean which will be initially false, and if you will find one in your array, then mark that. Okay, so you are done with this marking the presence of one. Okay, so suppose if after the first iteration, if after this iteration your this boolean one is false, then what it means? It means that one was not present. So if one was not present, then what would be your answer? I'll say you can simply return one from here, because one is not present in the array and one is the first smallest positive integer. Okay, so from here I will suggest you to return directly one. Okay, and I'll do the same. That is, I'll check if my one is present or not. If my one is not present, I'll simply return one from here, because one is the first positive smallest integer. Okay, now let us talk about how to mark out of range elements. So what will be the range of your what is the range of your numbers in this array? What could be? So I'll say the range could be from 1 to n, right? If n is the size of the array, then the number that can lie in this array would be 1 to n. Okay, 1 to n could be the numbers that we can get in this array. Okay, so now how we can do that? Let us see. Okay, so here also I have written that 1 2 3 4 5 6 7 would be the numbers that can come in this array. Okay, these are the numbers that can come in this array, so range would be 1 to n. So if any number is out of this range, then we have to mark that, and for marking that I will use in place of that I will use 1. Okay, in place of that number, in place of the number which will be out of range, I will mark that 1. Okay, why I will mark that 1? Because I will do something that will take that number to our range, right, to our range. So that is why I'll simply mark it 1. You can mark something else also, but I'm marking it 1. Okay, so suppose first of all we'll check for this. Okay, we in the same iteration we can do that. In the same iteration where we marked this as true, okay, where we did work for this boolean 1, in the same iteration we can do this also. Okay, so what we will do, simply check this one. If it is out of range, no, it is not out of range, so don't do anything, just go. Okay, now this here my iterator will come to 1. At 1, what we will do, we will simply check if it is out of range. Yes, it is out of range, so in place of this mark. Okay, it is marked. Now let us move on. This is 9, so 9 is out of range, so it will be 1. 2 is not out of range. 8 is out of range, so it will be 1. 1 is not out of range, and 3 is also not out of range. Okay, so this will be our array now. Okay, this will be our array now, and we have marked our presence is also true, right? 1 is true, and array will look like this. Okay, so we are done with the first step. We have marked the presence of 1. We have marked the out of range elements. Okay, so we are done with both of them. Now let us move on and try to see the second step. Okay, first step is done. Let us try to see second step. So in second step, what we'll do is simply here, let me change this array to the array that we have made. Okay, here we'll have 1, here also we'll have 1, here also we'll have 1. Okay, so we have this 1 1 and 1. Okay, these are 1 1 and 1. Now what I will do here, I will simply okay, I need to map element with indices, right? Map element with index. So how I can do that? Let us see. So keep them this side. So let us see how we can do that. So in this array, see, if it is a sorted array, suppose here, first of all, right now all the elements are in range. You can check them. All the elements are in range. No element is negative. No element is greater than n. Right? All the elements will lie from 1 to n. Right? Because I have changed I have in the previous step I have changed my out of range elements, and in the place of them I mark them 1, right? So here we get the presence of 1, and also we also are in range. Okay, all the elements are in range. So what we can do here, we have to map the element with indices. Okay, so how we can do that? See, first element that we are getting is 6. Okay, so in which index 6 can lie? See, 1 can lie at index 0, right? 2 can lie at index 1, 3 can lie at index 2. In the same way, 6 can lie in index 5. Upper one is index, lower one is number, and 7 can lie in index 7, right? So in this way we can write, right? We can describe some relation. In this way. So now we are getting ARR at I is equals to 6. Okay, array at I is equal to, so let me write array at I is equals to 6. Okay, so here we are getting 6. So if I'll mark it or I'll map this element with index, then what I will do, see, I will go to the index of it. That is my index will be, if this is the position, right? This is the position. The position of number 6 is 6. It is a 6 position, right? And the index is 5, right? So index is equals to position minus 1, right? This is position. So that is 6 minus 1 is the index. That is at 5 index, go to the 5 index, and any element that is sitting at the 5 index, mark that negative. Okay, why mark that negative? Because here I'm mapping my index and element. Okay, so let me do the same. I'll go to the 5th index and mark this negative. Suppose if it is already negative, okay, if it is already negative, then that means that I have made it negative, because when we are starting this loop, there is no number negative, right? No number is negative right now, but it could possible that when we'll reach to this index, we'll find that okay, this is already negative. Okay, so in position, when we are finding position, what we'll do, we'll take absolute of this array at I. Okay, we'll take absolute of array at I, and then after that we'll do position minus 1. Okay, so that we can reach to a positive index, because negative index does not occur in our array, right? There is no negative index in our array. So here we did the work for this, right? Here after this, at first index we got 1. So where we'll go to index 1 minus 1, that is 0, and at 0 we'll mark negative. At 0 we'll mark it negative. Okay, now at second we find 1. So we'll go to this array at I minus 1, right? This position is 1, so position minus 1 means 0 index. So 0 index, at 0 index mark negative. It is already negative, so don't make negative of negative. Take absolute of whatever array at position minus 1 is, take absolute of that, and then do negative of that, so that it can remain negative, because negative of negative is already positive. So you need to make sure that it will remain negative if it is negative. Okay, if it is negative, then also it will be negative. If it is positive, then also you have to make it negative when you are relating it with your element. Okay, so in this way, so where we are at 2, right? So at 2 also we got 1, so it will be negative. Now at 3 we got 2, so where we'll go to position minus 1, right? So position is here, right? We were here, so position is 2, right? So position minus 1, so we'll go to array at 2 minus 1. We'll take absolute of this, okay, and we'll do negative of that. So 2 minus 1 means array at 1 will be negative. Now after this we'll reach to this point, so this will make this one also negative. This is already negative, so we'll keep it negative. Now here at this point it is negative, right? So we'll take again absolute of this 1, and index is absolute of this 1. And now what we'll do, okay, this is not index, this is position for 5, right? For this index for 5, what we'll do, position is absolute of absolute value of array at 5, right? That means 1. Now index is, that means array at position minus 1. At array at position minus 1, do negative by taking absolute of array of position minus 1. Okay, that is, here it is 1, here it is minus 1, so we'll get position 1. Okay, go to the 1 minus 1 index. Okay, that is 0th index, and anything that is in that, do the negative of that. Okay, if it is already negative, do the negative by taking absolute value of that, so that it can remain negative if it is negative. Okay, so we'll go to again 0, it is already negative, so we'll keep it negative. Okay, now there's 3, so this 3 will say go to second index, that is this index, and do the negative of this. Okay, so now we are done with the iteration. Okay, now this is the result that we have. So now we need to find that which is the first positive, which is the first number that is missing, right? So what we can do for that? So for that, what we can do is, we have to find our answer now, right? We are done with the 2 step, and final step was, I said that, and in final step you have to find missing number. You have to find missing number, but for that you need to do one observation. What observation? See, this 0th index element became negative because of think. Suppose if I have 1 in my index somewhere I have 1, right? If this is 1, right? If I have 1, then that one, what that 1 will do, that 1 will go to index 1 minus 1 and will do negative there, right? And will make that negative. So if there is 1, then my 0 index is negative. Right? In the same way, if there is 2 present in that, that will take us to 2 minus 1 index, that is 1 index. Okay, and it will make this one as negative, right? Similarly, if 4 is present, in this array, then 4 will take us to 4 minus 1 index, right? And it will do negative there. Okay, it will do negative by going there. Okay, so this is what it will do. So that is why I'm saying that we need some observation. So with this observation, what we'll get is the number which is not negative now. The number which is not negative now, for that the I plus 1 element is absent. Okay, because see now find which number remained positive. This is negative, this is negative, this is negative, this one is positive, right? What it means? It means index 3 is positive. Index 3 is positive, right? Why index 2 is negative? So first of all, understand why index 2 is positive. Index 2 is, I mean, negative. Okay, why index 2 is negative? It is negative because when I found this element somewhere, right? When I found array at I is equals to 3, right? Array at I is equals to 3, then I made this as my position. Position is equals to array at I, right? This is what I was doing, absolute of array at I. And by going to the position minus 1, that is 3 minus 1, at index 2, I did negative. Right? This is what I do. That is why this 2 index is negative, because 3 was present. Now my third index is positive, so that means element 4 is not present, right? Element 4 is not present in this, so that is why we haven't got our answer. So suppose if all the elements are negative, all the elements are negative means all the elements are present in it. For 1 we'll have 2. Okay, 2 is negative because of 1. 2 is negative. This second index is negative because of 3 was present, and this 4th index was negative because of 5 number was present, right? Fifth index because number 5 was present, and this is number, this is index, right? This is number, this is index. 4 index is negative. 4 index is negative because number 5 was present. Okay, this is what I'm saying. So suppose if all are negative, then that means that my answer is n plus 1, right? Because from 1 to n all the elements are positive, that is why these indexes are negative. Okay, So n plus 1 is my answer in this case when I'll not get any negative, any positive integer in this array. But otherwise I plus 1 will be my answer. Why? I already have told you. Okay, so now let us try to look into the code of it. Okay, first of all let us see that is it the answer. Is 4 is the answer of it. So let us go back. It was the array, right? It was the array. So 1 is present, 2 is present, 3 is present, 4 is not present, so 4 is answer. 4 is first missing positive integer, right? So now let us try to write the code for the same. So let us go to the board and write the code. Okay, so let us now look into the code of it. Okay, so we were coding in Java, right? So let us write the code. So first of all, what we need to do, simply let us write the steps that we need to follow first of all. Okay, so the steps were, first step one was mark the presence of one, and also mark out of range elements, right? So this is what we should do. After that, what we should do in the second step, map elements with index. Okay, this will be the second step. And after this, what you should do, simply after mapping you should find missing element. Okay, these are the three steps. Elements. Okay, so these are the three steps. So what we should do, see, first of all I'll take bool 1 is equals to true. Okay, not true, false, right? Initially my 1 was not present, I think. Okay, so if I'll get 1, I'll mark the presence of 1. Okay, otherwise it will be false. Okay, but I also need array or array dot length, right? So here I have stored an array dot length in n, so n is now array dot length. So I run a loop for int I is equals to 0, I is less than n and I plus plus. So in this, what I should do, simply I should check if my array at I is equals to 1 or not. Okay, if it is equals to 1, then what you should do, 1 is equals to true. Okay, mark the presence of 1. Else if it is out of range, that means if array at I is less than 1 or array at I is greater than n. Okay, if any of this condition will hit, okay, then at that then this means that this array at I is my out of range element. So what I should mark it, array at I will become equal to 1. Okay, this is what I should mark. After this, suppose after coming out of this loop, if my 1 is false, then what it means? It means that 1 was not present, right? So what I should return from here, I should return 1. It is the smallest number, positive number, that is missing, right? I should return 1 from here. Now suppose if 1 was present, then that means that I should check for other elements, right? But for checking them, what I should do, I should map elements with index, right? Elements with index. I will follow my second step. Okay, map element with index. So how I will map it? Simply run a loop from int I is equals to 0, I is less than n, I plus plus. Okay, now check. Do not check, just take out the index position, right? So int position will be array at I. Okay, this is my position, but this could be negative, right? This could be negative because some element from the starting can make this one as negative. So I'll take the math.abs of this, right? Math.abs of array at I will give me the positive position, right? So now I will do array at position minus 1 equals to negative of math.abs of array at position minus 1. Okay, So simply this is what we need to do. Okay, at array at position -1, do negative. Okay, if it is already negative, then also keep it negative. Okay, that is why this map.abs. Okay, uh, and okay, we are done with mapping. Okay, we are done with mapping. So now we just need to find the missing element. So what would be the missing element? So missing element would be the element which has remained, negative here is my missing element, right? So I is equals to 0. I mean the element which remained positive, I is less than n and I plus plus. So if the number array at I at some point is less than 1, I mean less than 1, less than 0, right? Less than 0 means negative. So if a number is less than 0, then you should return I plus 1. Okay, because that number, if a number at any index, if a number at any index is negative, I mean is positive, right? Is positive, we should check if number is positive or not, because here we did a negative, right? We did negative. So here what we will check, if array type is positive at some point. If array type is positive, that means that I plus 1 element is not present in this array. Okay, it's because that is why it is positive. So suppose at this point this condition have not hit, right? This condition uh, was not correct at some point, right? This condition was not correct, so this condition haven't hit yet. That means that all the element in my array were negative. All the element in my array were negative. So what that means? That means that from 1 to n all the elements are present in this array. So what I should return? I should simply return n plus 1. Okay, because if 1 to n all the elements are present, from 1 to n, if all the elements are present, then my smallest number, then my smallest positive integer that is missing is n plus 1, right? So let us try to give it a run. Accepted. Let us try to give it a final submit for all the test cases. Cool. So completely accepted. So I hope that you got this question completely. Okay, it was an easy question, but tag was hard. Okay, we already have seen that how we have solved it. So we'll meet in the next video. Okay, that's all for this video. And if you like the video, you can like it, and also subscribe to our YouTube channel if you are new here, and share this video with your friends. So we'll meet in the next video. Now till then, goodbye, take care, bye.